Hey guys, welcome to this video on the 2020 level 3 calculus test. We did this test, I think it was last week, and I'll be going through this paper today. So question number A, question 1A. So differentiate y equals to square root of x squared plus ln of x. Right, for this question, we have a square root, and that means we're going to have to use the chain rule here. So instead of writing square root of x, we cannot differentiate straight away because we cannot differentiate the square root. So instead of saying square root of x squared plus ln of x, I'm going to say that x squared plus ln of x to the power of 1/2. That's the exact same thing as saying to the square root of, that's the exact same thing as saying square root. So I'm going to rewrite this. The first step, I'm going to say that y equals to x squared plus ln of x to the power of 1/2. Alright, so now our outer function would be to the power of 1/2, and our inner function would be x squared plus ln of x. So in this case, we're going to move the power to the coefficient, so 1/2 times of x squared plus ln of x bracket, and we're going to take the power down by 1, so 1/2 becomes negative 1/2, and then finally we're going to multiply by the derivative of the inner function. Okay, so the derivative of the inner function will be the derivative of x squared plus ln of x. X squared, you apply the power rule, it becomes 2x, and ln of x, you know, it becomes 1 over x. So to differentiate this, we can say dy over dx that equals to 1/2 multiplied by x squared plus ln of x to the power of negative 1/2 multiplied by the derivative of the inner function, which is 2x plus 1 over x. So in this case, you could simplify your expression, but usually for the first question, I didn't write the whole question, but for the first question, it says you do not have to simplify your answer. And when it says you don't have to simplify your answer in the exam, that means you can just leave your answer like this. There's no need to further simplify. If you keep simplifying, there's no extra credit if you simplify, so you might as well go to another question to save more time. So in this question, you can just stop here, and this is just an achieved level question. So this will be an achieved for the correct derivative. Now we're looking at question B. Find the gradient of the curve y equals to secant 2x at the point where x equals to pi over 6. So it wants us to find the gradient. So as soon as the question asks you to find the gradient, you know you're going to have to differentiate. So we know that secant becomes secant tan, okay? So in this case, we're going to say dy over dx that is equal to, so we have 2x in our inner function and secant is our outer function. So once again, we're going to be applying the chain rule. So we need to be multiplying by the derivative of the inner function. The derivative of the inner function is derivative of 2x is just 2. So we're going to move that to the coefficient. So we're going to say equal to 2 secant of 2x tan 2x. And that would be your derivative. So now we need to find the point where the gradient where x equals to pi over 6. So if you go to a calculator right now, you might notice that there's no button for secant. So there's actually no way to directly input secant 2x. But we also know that secant is actually equal to 1 over cos. So in this case, your secant 2x can be rewritten as 1 over cos 2x. So we're going to rewrite this derivative as dy over dx that's equal to 2 tan x. 2 tan 2x, apologies, divided by cos or cosine of 2x. Alright, so now we can substitute our x equals to pi over 6 and we can solve to our equation. So dy over dx that equals to 2 tan of pi over 3 because it's 2x divided by cos of pi over 3. So in this case, your tan pi over 3, that should be coming out to be square root of 3. Multiply that by 2, it should become 2 square root of 3. For your cos pi over 3, should be coming out to be 0.5. So once you have these two values, it becomes 2 root 3 divided by 0.5. And dividing by 0.5 is the same as multiplying by 2. So this simplifies to 4 root 3. And that is your gradient at the point pi over 6. So once again, this is just another achieved question here. So getting your correct gradient, you have to differentiate and find the gradient. That is your achieved grade there. Okay, looking at question C now. Find the x values where the gradient to the tangent at the of the graph f of x is parallel to the x-axis. So f of x is x plus 1 squared divided by e to the power of x. So looking at this question, there's actually a lot of ways you can do it. So one possible way that was actually suggested was if we move the e to the power of x to the numerator, which making it e to the power of negative x. The reason I really don't like that method is because once you do that, you actually have to use the product rule, and once you have something's x plus 1 squared and e to the power of negative x, it becomes really easy to make a mistake. So what I actually prefer in this case is just to use the quotient rule. So the quotient rule, if you cannot remember, quotient rule states that if we say that our top function is f and our bottom function is g, it's so our quotient rule states that f dash of g minus g dash of f over g squared. So that is our quotient rule. You should be able to find that on your formula sheet, but that's our quotient rule. So in this case, we can see we need to take the derivative of the f function, the derivative of x plus 1. The derivative of x plus 1 will take the power down to the coefficient, becomes 2 times of x plus 1. We take the power down by 1, so 2 times of x plus 1 to the power of 1 multiplied by the derivative of the inner function, which in this case is just 1, so we don't have to worry about it. So in this case, we have f dash of x that equals 2 times of x plus 1 to the power of 1 multiplied by 1, so you can just ignore it, times of g, which is e to the power of x, and minus g dash times of f. So you know the derivative of e to the power of, derivative of e to the power of x, that's still just e to the power of x. So we can say minus e to the power of x times of our f function, which is x plus 1 squared. And we should be dividing by our g function squared, so our numerator squared. E to the power of x squared, that's the same as saying e to the power of x times e to the power of x. If you have the same base, you can just simply add the power, so it becomes e to the power of 2x. Alright, so in this case, okay, you can see at the numerator, there's a common factor is e to the power of x. We can actually take that one out. So you can say f dash of x equals to e to the power of x, and that's factorize it out. So 2 times of x plus 1 minus x plus 1 squared divided by e to the power of 2x. So notice now we can cancel one of the e to the power of x with the e to the power of 2x at the denominator. So therefore, f dash of x equals 2. So if we expand this out, we can say 2x plus 2 minus x squared plus 2x plus 1 divided by e to the power of x. Once you get up to this stage, I want you to find the x values where the gradient of the tangent is parallel to the x-axis. So if you think about it, if I draw a really quick sketch in the corner here, so we have a sketch. So parallel to the x-axis, you know the x-axis is horizontal. Parallel lines never meet, so therefore our tangent is also going to be a horizontal line. What do you notice about this line? Well, the first thing you should definitely be noticing is that the gradient of this line is 0. And that's because the y values are not changing. So therefore, when it says parallel to the x-axis, it's the same as saying the gradient is 0. So basically, we're just solving for x when the gradient is 0. So once the gradient is equal to 0, so we know that f dash of x equals to 0, we can write that down. So f dash of x equals to 0. And e to the power of x times 0, that's still 0. So therefore, what we're really solving right now is just 2x plus 2 minus x squared. Minus x squared minus 2x minus 1, and that equals to 0. 2x and 2x cancel out. So therefore, what you're really solving right now is just negative x squared plus 1 equals to 0. So now you move the x squared to the other side. So x squared equals to 1, and x equals to plus or minus 1. Don't forget the plus or minus 1, and that's because once you take a square root, there is a possibility of both a positive answer and a negative answer. So if you do not include the plus or minus, you'll definitely get marked down for this question. That's guaranteed. So it's very important that you keep in mind that once you take a square root, there's always that positive and negative answer. So it's important to say plus or minus 1. Don't forget that. So in terms of marks for this question, getting up to x equals to plus or minus 1, that is should be a merit grade. In terms of getting an achieved grade, usually for these types of questions, once as a disclaimer, I don't have the marking schedule with me, so I cannot say for sure. So therefore, I'm only making some approximate guesses based on past year papers. So based on past year papers, I'm thinking that if you just find a correct derivative, so that's finding your f dash of x, that should be enough to get you an achieved. So this step here, that should be enough to get you an achieved. Alright, moving on to question D now. Right, so the parametric equation of a curve, it shouldn't say r, it should say is x equals to e to the power of 2t and y equals to t squared times e to the power of negative t minus 1. The question asks you to show that the second derivative is 3t squared minus 8t plus 2 over 4e to the power of 5t. Right, so in this case, you have both x and y given by another variable, which is t. So in this case, we can actually find the relationship between x and y if we are able to differentiate both of these equations first, okay? So first things first, if we differentiate both, we'll start with the x. So if we say dx dt, so differentiate x with respect to t. So derivative of e to the power of 2t. Remember that when we differentiate in an exponential function, we're going to take the derivative of the power and move that derivative to the coefficient. So in this case, the derivative of 2t is just 2. So 2 times e to the power of 2t. So dx over dt equals to 2 times of e to the power of 2t. Alright, to differentiate the y is a bit harder. You're going to have to be using the product rule. So the product rule states, so if you cannot remember, the product rule is f dash of g plus g dash of f. So basically, the derivative of one function times the non-derivative of the other, plus of the derivative of the other function, multiplied by the non-derivative of the first function, okay? So dy over not dx, sorry, that is dy over dt. And that's equal to derivative of 2t is just, derivative of t squared is just 2t. So 2t e to the power of negative t. And we need to add that on to the derivative of e to the power of negative t times of t squared. The derivative of e to the power of negative t, that's just negative 1. So therefore, this becomes negative because of the negative comes to the front. This becomes negative t squared e to the power of negative t. And then the negative 1, if we differentiate that, it just disappears. Right, so looking at this question now, okay, so now we need to find dy over dx. So dy over dx is what we're trying to find. We have dx over dt and dy over dt. So in this case, as you can see, we can actually treat this these two derivatives like a fraction right now. So we have dy over dt and dx over dt. Looking at dy over dx, we can see that the x is in the denominator and the dy is in the numerator. So the dy over dt, the dy is already in the numerator. However, dx over dt, the dx is in the numerator, which should be in the denominator. So automatically, we know we need to inverse the dx over dt and make it dt over dx. So we know dy over dx equals to dt over dx times of dy over dt. So in this case, the dt and the dt will cancel out to give you dy over dx. So therefore, this actually simplifies to 1 over 2e to the power of 2t times 2t e to the power of negative t minus t squared e to the power of negative t. Right, simplifying this equation, dy over dt, that equals to 2t e to the power of negative t minus t squared e to the power of negative t over 2e to the power of 2t. Right, so at this stage, you should notice that e to the power of negative t is a common factor. And once again, we can move e to the power of negative t to the denominator by making it positive power. So therefore, dy over, not dt, sorry, it's dy over dx, my bad. Okay, dy over dx that equals 2t minus t squared, because we're factoring out the e to the power of negative t. We're going to move that to the denominator. So therefore, this actually gives us 2e to the power of 3t. Alright, so the reason I did this, you might be asking me, what's the point of doing this? Aren't we just wasting our time right now? So the reason I did this is because if we want to find our second derivative, we're going to have to differentiate dy over dx with respect to t. And once we do that, if you notice that this we have to be using the product rule so many times if we have that e to the power of negative t in the numerator. Once we move the e to the power of negative t to the denominator, you notice that we no longer have to use the product rule in the numerator. And once we don't use the product rule in the numerator, that actually decreases our chance of making mistakes and therefore increases our chances of getting a better grade. So once we differentiate the dy over dx with respect to t, and we also need to multiply by dt over dx in order to get our second derivative, because we have a parametric function, so both x and y are related to a common variable here. Alright, so dy over dx, we're going to be using our quotient rule. So quotient rule, so dy over, d squared y, so second derivative, over dx squared, that equals to 2 minus 2t multiplied by 2e to the power of 3t minus, 2e to the power of 3t. Derivative of 3t is just 3. 3 times 2 becomes 6. So 6e to the power of 3t multiplied by 2t minus t squared over the denominator squared. So it becomes 4e to the power of 6t. Because once you square it, 2 becomes 4. E to the power of 3t becomes e to the power of 6t. And we need to remember to multiply by dt over dx. So dt over dx, we know it was, what was it again? So it was 1 over 2e to the power of 2t. So, so now all we need to do now is do a little bit of simplifying work here. So d squared y over dx squared, that equals 2. Alright, so notice, just before we continue, once again, notice that e to the power of 3t is a common factor, and we can actually make our lives so much easier by just factoring that one out. So we can say e to the power of 3t multiplied by, so the 2 here multiplied by 2 minus 2t, so it becomes 4 minus 4t, minus 6 times of 2t minus t squared, so minus 6 times of 2t minus t squared, divided by 4e to the power of 6t times 2e to the power of 2t. For e, you add the powers, and for the 2 and the 4, you just multiply them together. So it becomes 8e to the power of 8t. Once again, so now you can see e to the power of 3t. You can cancel 3t's out of the denominator and get rid of it completely. So dy over dx squared, that equals to 4 minus 4t minus 12t plus t squared. That's over 8e to the power of 5t, because we cancelled 3t out of the denominator. Alright, so make a mistake around here. 2e to the power of 2t. Oh no, I didn't make a mistake. What am I doing? Okay, d squared y over dx squared. Sorry guys about that. I thought I had made a mistake, which I didn't. So 4 minus 16t plus t squared. Sorry, plus 6t squared. Sorry, that's the multiply by 6 inside, so that's 6 there. So plus 6t squared over 8e to the power of 5t. So notice that 2 is a common factor, so we divide everything by 2. So d squared y dx squared, that equals to 2 minus 8t plus 3t squared over 4e to the power of 5t. And as you can see there, that is exactly equal to the second derivative given in the question. So therefore, that will be your final answer. So this is your final answer here. And this is actually a merit level question. In my opinion, this is a pretty difficult question for a merit grade. This is if there's boundaries for merit grade, I would definitely say this is towards the higher, more difficult merit side. But nonetheless, this is still a merit level question. So getting your final second derivative, that will get you a merit grade. To get an achieved grade, if you can find your dy over dx, for sure that will get you an achieved. Alright, so that's question D. So question E now. So question E, a rectangular box with sides of different lengths as shown in the diagram has a volume of 32 meters cubed. What are the dimensions of the box so that the surface, that should say area? The surface area is a minimum. Alright, so for this question, okay, so in order to find the surface area, because we have two different variables, we have x and y, we actually need two different equations in order to write one in terms of the other. And that's perfectly convenient because we have volume equals to 32 and we're trying to minimize the surface area. So best thing to do here is actually to set up our equation for our volume. So volume we know equals to, red pen. Volume equals to base times height times width, okay? And that's equal to 2x times of x times of y. And that actually equals to 2x squared y. So we know the volume is 32, so we can directly plug that in. So 32 equals to 2x squared times of y. Divide everything by 2, so 16 equals to x squared y. Alright, so just going to leave this equation here for now, and we're going to find out an equation for our surface area. So our surface area, as you can see here, we have we have 2x squared here, and on the other side we also have 2x squared, so therefore our area equals to 4x squared. On the side here, so on this side here, we have our x times of y, so plus xy, but however we still have xy on the other side as well, so that becomes 2xy. So we're going to add 2xy. And looking at this top surface area now, so at the top here is 2x times y, that becomes 2xy. And don't forget, we also have the same surface at the bottom, so that's actually 4xy. And that equals to 4x squared plus 6xy. Right, so in this case, we need to find x in terms of y or y in terms of x. So you might be asking, oh, which one should I use? So as you can see in this area formula, we have x squared, we have x, but however, we only have one y by itself. So as you can see here, it's obviously a lot easier in order to make x to make y the subject of the formula. So once you make y the subject of the formula, you only need to replace it once in the equation, and that makes your life actually a lot more easier. So we know that 16 equals to x squared y, so therefore 16 over x squared, that equals to y. So we're going to substitute 16 over x squared in terms back as y. So area equals to 4x squared plus 6x times of 16 over x squared. So therefore area equals to 4x squared plus 96 over x. Alright, so therefore area equals to, actually we can just differentiate now. So differentiate with respect to x. So dA over dx, that equals to 8x plus of, so in this case this can be rewritten as 96x power of negative 1. And once again, you can just apply the power rule. So this becomes negative 96, and then the power gets reduced by 1, becomes x to the power of negative 2. Move it back, you can move that back to the denominator. So that becomes negative 96 over x squared. Alright, so at this stage, you can actually say that the dA over dx equals to 0 because we're finding a minimum turning point. You can say this is a minimum. What is a minimum or maximum? Yeah, minimum turning point. So minimum. So therefore, 96x squared, that equals to 8x. At this stage, we can get rid of the x squared in the denominator by multiplying both sides by x to the power of 2. So if we multiply both sides by x to the power of 2, we get 96 equals to 8x to the power of 3. So therefore, if we divide by 8 on both sides, 12 equals to x3. Therefore, x equals to the third root of 12. So you can actually just leave your answer like this for now. So therefore, we know x is equal to the third root of 12. And therefore, we also know that 16 equals to x squared times of y. And if we square x, so we also know that x squared equals to 12 to the power of 2 over 3. And if we substitute that back in, so we can say 16 over 12 to the power of 2 over 3, that equals to y. So therefore, we have our three sides. We have x, we have 2x, and we have y. And if we convert these to decimals, you don't have to convert it to decimals, but if you wanted to, so 12 to the power of 1 over 3. So we have 2.289 meters here. We have 4.579 meters here. And we have 12. And for y, we have 3.053 meters. So those are our dimensions of our rectangle, and that should be our final answer. If we wanted to, we could also do the second derivative test here, but in this case, it's not that necessary since you only came up with one answer. But we'll just do it for the sake of doing it. So d squared a over dx squared, that equals to 8. So to differentiate this, we can move the x squared to the top to becomes x to the power of negative 2. Negative 2 times negative 96, so that becomes 192. So double negative makes a positive over x to the power of 3. So if we substitute our 2.289, so d squared a over dx squared equals to 8 plus of 192 over third root of 12, that actually simplifies to just 12 there. So that gives us 24. This is positive, so therefore this is minimum. And that's actually all you need to do for this question. And you don't even need to do the second derivative test if you didn't want to. But we just did it for doing it, just extra. So if you get the correct dimensions here, you'll get an excellence grade. To get a merit level grade, Merit level grade could be finding this x value. And achieved grade. Achieved grade could be differentiation. That could get you an achieved. I think, yeah, that makes sense. Okay. So achieved for differentiating, merit for finding the x value, and E for your final answer. Alright, so question 2, this is actually question 2 now, I forgot to label it. So question 2, differentiate y equals to 4e to the power of x squared minus 6. Alright, so once again, we're just going to be applying our differentiating e. So we're just going to take the derivative of the power and move it to the coefficient. So derivative of x squared minus 6, that's just 2x. So 2x times 4, that becomes 8x. So therefore our dy over dx, that equals to 4 times of 2x to e to the power of x squared minus 6, and therefore dy over dx equals to 8x e to the power of x squared minus 6. And that's your final answer. That's all you need to do. And that's an achieved grade there. Alright, question 2. Find the rate of change of the function f of x equals to 4 ln of x over x to the power 3, where x equals to e. Okay, so for this question, we probably should be using our quotient rule here. So quotient rule for this question. So the derivative of the upper function, well, not the upper function, well, the derivative of the numerator, that is just ln of x becomes 1 over x. So that becomes 4 times of 1 over x, that becomes 4 over x. So therefore 4 over x times of x to the power 3 minus derivative of x to the power 3 is 3x squared times of 4 ln of x. And that's the whole thing divided by x to the power 6. Alright, so this actually simplifies too, so we can cancel one of the x's in the numerator of the denominator, so that becomes 4x squared minus 12x squared. Because the 4, you can multiply 4 and 3, so 4 times 3 is 12, 12x squared ln of x divided by x to the power 6, and that is our f dash of x. Alright, so f dash of e, so substituting e to find the rate of change, that gives us 4e squared minus 12e squared. Ln of e, we know ln is basically asking us the question, e to the power of what is x? So e to the power of 1 is e, obviously. So e to the power of 1 is e, so therefore ln of e is just 1. We can get rid of it, we don't need that there. So therefore divided by e to the power of 6. At this point, there's really no need to simplify any further, but if you wanted to, you can actually take the e squared out, becomes 4 minus 12 over e to the power of 6, and that becomes negative 8 over e to the power of 4. And that should be your final answer, and this is an achieved grade. Question C. Okay, this question. So this is f of x. I forgot to label this graph as well. Apologize. So f of x is this graph here. And the question is asking us, find all the values of x where f of x is not differentiable. So when it says not differentiable, we know that these points are points that are non-continuous or they are sharp edges. At this point, we know that the white circles, that means that the graph is not continuous, and so therefore we know that x equals to 2 is not differentiable. We know x equals to 3 is not differentiable because they're both represented by the open circles, not white circles, so open circles. We also know that if there's an asymptote, like for example at x equals to 5, there's an asymptote that is also not differentiable. And we also know that at a black dot, that represents that the graph is not continuous. And like I just said, if the graph is not continuous, then therefore it is not going to be differentiable. So there's actually going to be 4 points here. So the 4 points is going to be x equals to 2, negative 2. We have x equals to 3, and we have x equals to 5. So those are the 4 points there for this question, because these points are either not continuous or there's an asymptote. So question 2, what is the limit of f of x as x approaches 2? So the limit is basically asking us, what does the graph appear to approach as it approaches a specific x value? So in this case, as f of x approaches 2, even though the actual defined value at x equals to 2 equals to 1, that's not the limit, because both directions of the graph is both approaching to y equals to 3. And because both sides of the graph are approaching y equals to 3, therefore there's the limit, and the limit is actually equal to 3. So we can just say this is equal to 3. We don't need anything else, so equal to 3. Question 3. So find all the values of x that meet the condition that f of x is greater than 0, or in other words, the graph is increasing. So increasing, okay, that's pretty, we can look out for that pretty easily. So as you can see, the linear graph from -2 to 3, that's increasing. And we could also note that the graph is increasing in the second half of the parabola. So after the turning point in the parabola from -5 to -2, that is also increasing. However, when you're writing your boundaries, be careful to not include some of the points. Because, for example, for your linear graph, because x equals to 2 is not differentiable, x equals to 3 is not differentiable, it's imperative that you do not include these points. And how do you not include these points? You can just say, for example, x is not equal to, x is not equal to 2. That's how you exclude a certain point. And it's important that you exclude all the points that are not differentiable, because f dash of x means differentiating, and if a point is not differentiable, then it obviously cannot have a gradient greater than 0. Right, so writing this answer to this question, we can say that x is between -2 and -5, but not including those points, because at -5 the gradient is 0, it's not greater than 0, and at -2 it's an closed dot, is not differentiable, so therefore we do not include that either. And we also know that this is between the linear graph -2 and 3, so x is between 3 and -2. However, for these boundaries, we know x cannot be 2, so we can need to write down that x cannot be 2. For x equals to 3, you already said that x must be less than 3, so therefore we do not have to write that again. Alright, so that's all the graphs that are increasing. So what is the value of the limit as x approaches 5? So as you can see, as x approaches 5, there is it's actually an asymptote, so it's actually approaching -infinity and positive infinity. Because these limits, they're approaching different values, -infinity and positive infinity, therefore there's actually no limit there. Okay, if they are both approaching to the same y value, then there will be a limit. However, in this case, there is no limit because they're not approaching to the same value, so does not exist. So just write do not exist, okay? Don't write anything else. Don't write oh no. Don't write no. Don't write anything else. Just write does not exist, because they want you to state clearly. So usually a question would be like state clearly if the limit does not exist, okay? State clearly if limit does not exist, okay? So just say does not exist if it doesn't exist. So don't go onto a tangent and say oh no. Don't say any of that. Just say does not exist, okay? Okay, so looking at the last graph here, last question. Find all values of x that meet the condition that f of x, so the second derivative of x is less than 0, or in other words, it's concave down. So what I like to remind people when they say concave up or concave down is I like to say, oh, look for the happy face. If it's a happy face, then it's concave up, because when you're happy, you're obviously feeling positive, you're feeling up. If it's a concave down, then obviously you're feeling down, you're feeling sad, therefore you're going to be looking for that sad face. In this case, you're going to be looking for that sad face here. It might not be completely obvious to you at first glance, but if you take note of x is between 5 and 3, you can see that this is part of a parabola, and if I extend this down, then you'll see that there's indeed a sad face there. So therefore we can say that the graph is actually concave down between x equals to 5 and x equals to 3, but not including those points, because at x equals to 5 and x equals to 3, the graph is not differentiable, and if it's not differentiable, then therefore they cannot have a second derivative at those points. So therefore between 5 and 3, so therefore we'll say that x is between positive 5 and positive 3, and we'll leave it at that for our answer. So that will be our answer. So for this question, it's usually that if you miss one question, you'll still get a merit grade. So basically, how many questions? 1, 2, 3, 4, 5. 5 questions. So typically, if you get 4 out of 5, that equals to a merit. If you can get up to 2 or 3, I'll say 3 out of 5, that can get you an achieved. Okay, that's how they normally do it for this question. So 4 out of 5 is a merit, or 5 out of 5, of course. 5 out of 5 is the best. 5 out of 5 is also a merit. And if you get just 3 out of 5, then you still can get an achieved. Alright, so a function is defined parametrically at x equals to e to the power of 2 over pi times t minus 2 sine t, y equals to 6 cos of 1 over 2t. Find the equation of the should say tangent. I don't know why it says that. So finding the equation of the tangent at t equals to pi. So I don't know why I put these questions so close together. So I'll just go straight to the back of the book. One of the book. Well, let's go straight to the back here. So we have e. Sorry, it's in black pen. E to power of pi over 2. Pi over 2, what was it? Pi over 2 times t minus 2 times of sine t, and that was our y. Actually, it was our y. Let me just, sorry about this, guys. So pi sine t, so x equals to that. Okay, so x equals to, so this is our x, and our y equals to 6 cos of t over 2. So when you're solving, so you want to find the tangent at x equals to t, I think it was. Okay. For this question, okay, you need to find the derivative and solve parametrically to find dy over dx. So because we have x in terms of a variable t and y in terms of a variable t, we can find the relationship between x and y, okay? So let's differentiate y first, okay? Let's start out with the easier one. So dy over dt. We know that positive cos differentiates to negative sine, so our cos goes to negative sine, and however, we cannot forget that we need to multiply by the derivative of the inner function using the chain rule. So we know that the inner function is t over 2, the derivative of t over 2 is just 1/2, 6 times 1/2 is 3, but however, don't forget the negative 3 because it actually becomes negative sine. So dy over dt becomes negative 3 sine of t over 2. Nice and easy. So dx over dt, so in this case we're going to be using our product rule because we have sine t and we have e to power of pi over 2t minus 2. Derivative of sine t, that's just cos t, positive cos t. So we'll just write that down first. So cos t times of e to power of pi over 2t minus 2. Because when you're applying the product rule, you want to find the derivative of one function multiplied by the non-derivative of the other function, added on to the derivative of the other function multiplied by the non-derivative of the function that you found the derivative in the first part of the derivative, okay? So we're going to add this one on to. So derivative of e to power of pi over 2t negative minus 2. So derivative of pi over 2t minus 2, that's just pi over t. So we're going to move the pi over 2 to the coefficient. So it's plus of pi over 2 e to power of pi over 2 t minus 2. And don't forget to multiply by your sine t there. So that's your dx over dt. And like we said in the previous parametric equation, we know dy over dx equals to dt over dx times dy over dt. Okay, so if we find the inverse of dx over dt, so dt over dx that equals to 1 over everything we found here. So cos of t, e to power of 5 over 2, not 5, why did I say 5? Okay, pi over 2, pi over 2t minus 2 plus pi over 2 times e to power of pi over 2t minus 2 sine of t. So that's our dx over dt, and therefore our dy over dt will be the negative 3 sine t over 2 multiplied. So that equals to negative 3 sine of t over 2 divided by, I have to write this again. Okay, so the cos of t e to power of pi over 2t minus 2 plus pi over 2 e to power of pi over 2t minus 2 sine of t. Okay, finally got that out of the way. So at this stage, you can try to find your gradient function. So to find your gradient function, all you need to do is plug in our t value. So we said finding the equation of the tangent at x equals to t. So we need to find our gradient at x equals to t, and we can establish our gradient of our tangent graph, okay? So dy over dx that equals to negative 3 sine of t over 2, so that becomes pi over 2, divided by cos of pi e to power of, okay, so t equals to pi, so sorry, it's actually 2 over pi, wasn't it? Sorry, just realized. So 2 over pi, that is not pi over 2, that's pi 2 over pi. Apologize. So 2 over pi, that is also 2 over pi. Sorry guys, that should be 2 over pi. 2 over pi. Okay, I think you get the point, but 2 over pi. Okay, apologize for that, guys. So it should be 2 over pi. So times e to the power of, so we know it's 2 over pi. So when t equals to pi, the pi in the numerator cancels out with the pi in the denominator. So pi cancels with pi, and then it becomes 2 minus 2. So therefore it becomes e to the power of 0 plus 2 over pi e to the power of 0, once again, sine of pi. Okay, so you can use your calculator if you want. So pi, so sine of pi over 2, that is equal to, oh sorry, I'm on degrees. Sine of pi over 2, that equals to 1, so negative 3 over cos of pi, we know that's just negative 1, that becomes negative 1 plus of, we know that sine pi is 0, so anything times 0, that's still 0, so negative 3 over negative 1 plus 0, that equals to positive 3, nice and easy. So y equals to 3x plus c. So that's establishing our tangent graph, because we know y equals to mx plus c. M is your gradient, c is your y-intercept, okay? So now in order to find our y-intercept, we need to plug in t back into our x and y equations, okay? And this is actually 2 over pi, okay? So apologize for that. So 2 over pi. So we need to substitute t back into our x and y equations and find the x and y values at t equals to pi, and use these x and y values in order to find out our y-intercept, okay? So first thing first, we know that y equals to 6 cos of pi over, not pi, t over 2. And therefore y equals to 6 cos of, we substitute pi, we'll get pi over 2 here. Alright, so cos of pi over 2, we know that is 0, so therefore y equals to 0. We know we know x equals to e to the power of 2 over pi t minus 2 times of sine t. Once again, we know sine pi, that equals to 0, so therefore x also equals to 0. So quite interestingly enough, we have x equals to 0 and y equals to 0. So substituting these numbers back into our linear graph, we have 0 equals to 3 times of 0 plus c, and therefore you can figure out that c equals to 0, and therefore our equation is simply y equals to 3x, and that will be our final answer for this question, and this is a merit level question. To get an achieved level grade, you just need to find the derivatives. So dy over dx is found. So dy over dx, that will get you an achieved. Alright, so looking at question E now. So question E, did I put that one? Question E, the trough filled with water at the rate of 120 milliliters per hour. The end of the trough is an isosceles trapezium, and it's a space with dimensions as shown in the diagram. At what rate will the height of the water be changing when the water level is 10 centimeters? When you see these rate of change questions, I really strongly suggest that you write down everything you have and what you need to have in order to solve the question. So before you even start looking at the trapezium, before you start looking at the whatever it is, before you start looking at the diagram or at the information, you're going to write down what you have, what you're trying to find, and what you need in order to find what you need to find. Because what's the point of looking at all of these graphs and all of these diagrams if you don't even know what you want? Okay, so you need to know what you want first. Okay, so we know trough filled with water at a rate of 120 milliliters per hour. Milliliters, you can approximately assume that 1 millimeter, you can roughly assume 1 milliliter is roughly about 1 milliliter was, what am I doing? 1 centimeter, that's right, 1 centimeter cubed, okay? So assuming this assumption, so therefore we're actually given the rate of change of volume here. So we're actually given the amount the volume is changing per second. So we know that it's filling with water 120 milliliters an hour. Therefore the volume is increasing at 120 centimeters cubed per hour. So therefore dV over dt, we know that's 120. Okay, so that's writing down what we have. What we want to find is the height rate of change of the height of the water when the water level is 10 centimeters. So when you see the rate of change, rate always refers to time, okay? So rate, so what is just changing is at a rate is changing with respect to time, okay? So therefore, we're trying to find dH over dt. We know we have dV over dt. So this is what we have right now. So dH over dt equals to dV over dt times of something. We know we want to get rid of the dV. We don't like dV because we don't have that in our equation. So therefore, we're going to cancel it out by putting a dV in the denominator. So as you can see here, dV and dV will cancel out. And we need to introduce a new variable h. So therefore, we need to introduce dH. By doing this, now you know what you need to find. So now all of a sudden you know that you need an equation of h and v together, and you need to differentiate that equation in order to find your dH over dV. So now you know what you have, now you know what you need, now you can begin to look at the question in more detail. Alright, so the trapezium, okay, so right now we have a trapezium with a volume, okay. So first of all, let's just derive a formula for the volume. So we know that we know that the volume is equal to the cross-sectional area multiplied by the length. The cross-sectional area we'll just write as A for now, times of 120, which equals to 120A. Alright, so one thing we do know is that the trapezium is an isosceles trapezium, and that actually helps us a lot, surprisingly, if you do not believe so. Isosceles trapezium means that this side here, so this side, we'll call this whatever. What are we calling this? Okay, we'll call this Z, and we'll call this Z. So we know that Z, these two are both Z, they're both equal because it's an isosceles triangle, an isosceles trapezium, okay? Alright, so I heard some people, they said that, so because the area of a trapezium, we know the area of a trapezium, so we'll say A1, that's area of trapezium, that equals to 1/2 of A plus B times of H. So I saw some people, they said that, 26 over 16, that must be equal to, A over B. However, this isn't actually correct, because if you consider the water surface here, then that ratio actually doesn't stand for all of these values, so therefore that's actually an incorrect ratio. You cannot use that one there, okay? So what we do know, so we know for no matter what the water level is, so even as soon as you start pouring water in, you know that this space will be 16 centimeters no matter what. So we know this space is always 16 centimeters, because think about it. So as soon as you pour water into this trapezium, the water, no matter how much water is there, you know that that base is 16. So once you pour water in, the water level rises. We know that both the height increases and both the B value increases. So the B value increases and the height increases, but the A value stays the same. So what we can write down straight away, we know that A equals to 16 centimeters, done and dusted, okay? We know A equals to 16. The more troubling thing is, now we need to find an equation for for height in terms of height and the A value, okay? So once again, I heard some people saying that, because it's 26 here and 30 here, so that means that A over H, that must be equal to 26 over 30. Once again, that's not right, okay? So we need to, so if you look at the water level here, so that's our water level, and that's our, just ignore that one there, so just, alright, so we know that this here is 26, this is 30. Alright, so we know that this is always 16. However, this height here is just H. And we know that this, just by looking at the diagram, you can tell that it's just implausible. Because when this H is very small, let's say as soon as we start pouring water in, the moment we start pouring water in, we know that H is, the moment we pour water in, so we can say H is very small, let's say H is equal to 1 millimeter. So once you know H is 1 millimeter, we know that the B value is also roughly 16. So thinking about it, that's actually not correct, because you're saying that A over H is 26 over 30. However, this has to be true for all of the water levels, right? In order to make this assumption, this has to be true for all water levels. However, if you think about it, the moment you start pouring water in, we'll say the H is 1 millimeter. So if h is 1 millimeter, then we know that the water level is very, very low. And when the water level is very low, you know that the B value is roughly equal to the A value because the water hasn't started rising yet. So it's roughly equal to the A value. So therefore, you're actually saying that, so in our assumption, basically we're just saying that 1 millimeter over 16, that's equals to 26 over 30. So obviously you can see this is not equal. This is an incorrect assumption. And it can be very, let's just say deadly if you use that kind of assumption. So always think about what assumptions you're gonna make and if they make sense. Okay, first of all, you need to make sure they make sense. Okay, if they don't make sense, then it's not right. Okay. All right. So if we look at this cross sectional again, so log cross section should be not wrong way. Alright, so one thing we do know, so if we drew a triangle here and draw a triangle here, let's say we call this angle theta for now, okay? And let's say this is our water level, okay? Let's call that angle theta for now, okay? And we know that because this is an isosceles trapezium, we know that this whole length was 26 centimeters. Therefore, because both sides are equal, sorry, we know this is 16 centimeters, sorry. Because we know that both sides are equal, that means 26 minus 16 is equal to the edges that are sticking out. Because there are two edges sticking out, we know that both of these edges are both correspondingly 5 centimeters each. And this is angle theta as well, because once you know, because the reason we can actually make this assumption is because the question specifically tells us that it's an isosceles trapezium. Because it tells us it's an isosceles trapezium, that means both of these sides must be equal, okay? So looking at this question here, we can actually see that our tan theta, looking at this big triangle here, so this triangle, so let me highlight this triangle. What we're looking at right now, we're looking at this triangle here. If we look at this triangle here, we know that tan theta equals to 5, sorry, red pen, so equals to 5 over our h value. But in this case, it's our whole h value. As you can see, this is actually our geometrical reasoning here. So this long edge is actually our whole h value, which is actually just 30. So therefore, tan theta equals to 1 over 6. Okay, so now we can use similar triangles because we know that corresponding angles on parallel lines, they're equal. And therefore, we can actually use similar triangles, okay? Because this is 90 degrees, this is 90 degrees. And therefore, this angle and this angle are equal because it's actually corresponding angles on parallel lines. Parallel lines are here, okay? Because they're parallel and all the angles are equal, we can use our similar triangles, okay? Therefore, tan theta is equal to our instantaneous, so when whatever height, tan theta equals to whatever our, this x value, we'll call this side x. Whatever the small x is divided by our h, okay? So therefore, tan theta equals to x over h. 1 over 6 equals to x over h because we plug in tan theta is 1 over 6. And therefore, 1 over 6h equals to x. Alright, so you know that there's an x at both sides, so this is also x here. So technically, there's an x on both sides, so therefore, we actually have to take two x's, okay? So 2x's equals to 1 over 3h. So you have 2x equals to 1 over 3h. How does this help us? So we know that x is just the side sticking out of the trapezium. So we know that this 2x is actually representing that the side sticking out of the x. So that equals, so this is actually equal. So this is representing the a. So we'll call this the, this is the b value. We'll call this the b value. And this is equal to the b value plus 2x. However, we know that the b value is actually equal to 16, which is just this length here, plus of 2x, if you can see here. So this is 16. And this is x here and x here. That gives us our b length, okay? So therefore, we can say that b equals to 16 plus 2x. Therefore, b equals to 16 plus 1 over 3h. And now we have all the information we actually need in order to solve our equation. So know that our area equals to 1 over 2 a plus b times of height. So we know a equals to 16 and height equals to just height, because right now we're trying to find our rate of change. And because originally, remember, the very first step we did, we wanted to find our dh over dv, and now we have our h by itself independent of h. So now we can actually find the derivative, okay? Well, not quite find the derivative, but we can simplify this equation a little bit. So 16 plus 1 over 3h times of h. So a equals to 1/2 times of 32 plus 1 over 3h. Therefore, A equals to 1 over 2 times of 32h plus 1 over 3h squared. Okay, so we move this 1/2 in, so therefore A equals to 16h plus 1 over 6h squared. Okay, so some people made the mistakes or some people might be inclined to just differentiate now. However, remember very clearly, so at the very first step, I told you guys to find out what we wanted to find. What we wanted to find was dh over dv. Right now we have area in terms of height. Is that what we want? No, it's not what we want, because we want the volume, right? So we know that volume was equal to 120 times our cross-sectional area. Therefore, V equals to 120 times of 16 plus of 1 over 6h squared, okay? Sorry, there's a h there. Okay, 120 times 16, that equals to 1920h plus 20h squared. That's equal to V. Now we can actually differentiate, which is very good for us. So dV over dH, that equals to 1920 plus 40h. Right, so dV over dH equals to 1920 plus 40h. However, we want dH over dV. We need to inverse it, okay? So dH over dV, that equals to 1 over 1920 plus 40h. Right, so now coming back to our very first equation, we know that our dH over dt equals to dV over dt times dH over dV. We know our dV over dt, that's how fast our volume was increasing. It was pouring water in at 120 milliliters per hour. Therefore, our dH over dt equals to 120 over 1920 plus 40h. Now we can substitute our h is equal to 10 centimeters, because that was what the question was asking. What is the rate of change of the height when the height is 10 centimeters, when the water level was 10 centimeters, or as also they mean that the h is 10 centimeters. So dH over dV, that equals to, no, not dV, dt. That equals to 120 divided by 1920 plus 40 times of, what was it, 10. Okay, so 1920 plus 400, 120 divided by answer, and that, that made it 120 divided by 40, 400. Was it 10? That's 10. Yeah, 10. Okay. Oh, I might have made a mistake somewhere here. Let me just double check. 1 over 2, so 16h plus 1 over 6. 120, wasn't it? Yeah, 120. Okay. 120 times 16. 20h squared. Yeah, 100,020 plus 40h dH over dV. Yeah. What did I do wrong? 16 plus 2h, 16, 3h times of h. 120. Sorry guys, I'm trying to find out what I made. I do not recall what's being the answer, so plus dV of dt, so plus 100, 1020. Is this? Do not recall this being the answer. That's the problem. 1920 plus 400. What did I mess up? Oh gosh. Okay, guys. I know exactly what I messed up. So, okay, so the trough full of water is actually increasing at a rate of 1,200 milliliters per hour. I misread it as 120. Apologies, guys. It's actually 1,200. Okay, I'm apologizing if you guys were doing this the whole time and got confused. So it's actually dH over dt is actually equal to 1,200. No, not dH, dV. Okay, so that's my problem here. So if we add another 0 here, that will give us the right answer. So apologies for that, guys. I misread the question. So therefore, 400 plus 920, 1,200 divided by the answer. So therefore, this equals to 15 over 29 centimeters per hour. Okay, it's centimeters per hour because the height is measured in centimeters, and the water was increasing per hour. Okay, it was increasing per hour. Therefore, this height is also increasing at 15 over 29 centimeters per hour in hours. Okay, so yeah. So once again, I apologize for accidentally writing 120 there. So this rate here was actually 1,200. Okay, 1,200. So I apologize. Alright, so okay, so I was thinking of this is an excellence of a question, by the way. So excellence for getting up to the final answer. For a merit, where would the merit be? Merit might be finding this area formula might get you a merit. To get an achieved, maybe some reasoning here to get an achieved. I'm not too sure how they did this question, but somewhere along the lines there. Yeah, okay. Alright, so once again, I apologize for forgetting though that was 1,200, not 120. But I hope that you understand what I did for this question. Alright, so in terms of question 3, I'm going to leave that to the next video because once my screen recording gets too long, there's a good chance that I might cut off. So I'm just going to push question 3 to the next video, and that will be out very shortly. Okay, so if you're watching this, it should already be out. If it's not, just wait for a couple minutes, should be out. Okay, so thank you for watching this video. I hope you enjoyed. If you did enjoy, please drop a like and comment down below, and